Hello, today we're going to be learning about section 2.1, which is an introduction to integers. And before we even talk about integers, I wanted to remind you what whole numbers are. So, what is a whole number? Well, the whole numbers starts with 0, and then it's all of the positive counting numbers. So 0, 1, 2, 3, 4, 5, etc. And it goes on forever. So 0, 1, 2, 3, 4, and then I'll just put 3 dots to show that this set goes on forever. Those are the whole numbers. Most of you probably are very familiar with the whole numbers. So we say it has 0 and the positive counting numbers. The reason 1, 2, 3, 4, those are considered counting numbers is because they're numbers you can count to on your hand, and you don't have any fractions or decimals. Okay? But obviously the title of the section is not whole numbers. The title is actually integers. So what are integers? Integers are, they include all the whole numbers, okay? But they also include all of the negative counting numbers. Okay, so instead of starting at 0, they start all the way at negative infinity, okay? So I'll put 3 dots at the beginning, and we have all of the negative counting numbers, so negative 4, negative 3, negative 2, negative 1, and then it also includes all of the whole numbers. So it's also going to include 0, 1, 2, 3, 4, etc. Okay? So you can kind of think of the whole numbers as a part of the integers, right? Because the whole numbers include 0, 1, 2, 3, 4, etc. But the integers also include all of the negative counting numbers. And these 3 dots here means it goes forever. So for example, negative 103 would also be an integer. Okay, so that's the basic idea with what integers are. And then the next thing I wanted to talk to you about was actually the number line. Many of you have probably seen the number line before, but I wanted to show you what integers look like on the number line. Okay, so the number line. When people are writing the number line, they make a horizontal line. And usually in the middle of the line, you're going to have 0. And then since we're doing integers here, to the right of 0 you have the positive integers. So you have 1, 2, 3, 4, etc. And then to the left of 0 you have the negative counting numbers. So you're going to have negative 1, negative 2, negative 3, and negative 4. And so forth. Obviously, you can't write all of them because it goes on forever. But that's the picture. And the way this works is smaller numbers are to the left. Okay? So lesser, or let me say it this way. Less than goes to the left. Sorry, having trouble with my pen right now. Less than goes to the left, and then greater than goes to the right. Okay, so and less than is a symbol that you write with, it looks like a caret pointing to the left, whereas greater than is a caret pointing to the right. Okay, so what does that mean? Well, that means that if a number is left to the left of another number, it's less than, whereas if a number is to the right of another number, then it's greater than. Okay, so let's see an example of this. Okay, so example. Insert less than or greater than in between the pair of integers. Okay? Insert less than or greater than in between the pair of integers. And we're going to be putting in a less than or a greater than in between the pair of integers to make the statement true. To make the statement true. Okay. And we'll do a couple examples of this. So let's start with number 1, part 1 of our example. Let me pick a couple of numbers. So let's do 0 on the left and -3 on the right. Okay, so 0 and -3. So the question is 0 less than or greater than -3? And how do we do this? If you can do it in your head and you can do it reliably, then you just go ahead and put it down. But if you can't, what you do is you go up to your number line and you graph both 0, which is going to be right here, and -3, which is right there. Okay, so 0, here's 0, that's right there. That's in the middle of the number line. And then in another color, I'll graph -3. Okay, so -3 is over here. So then the question is 0 greater than or less than -3? Well, what we can see here is that 0, the red dot, is actually to the right of -3, which is the blue dot. So 0 is greater than, it's to the right of -3. So 0 is greater than -3. So we go ahead and put in a greater than symbol here. Okay, so we go ahead and write greater than. Okay, and you don't have to use the different colors. I'm just using that for my presentation to make it easier to understand. Okay? And something else that we're learning here, as I did this problem, what we did there is we actually graphed 0, and we also graphed -3. So when I put in those points, we were graphing the integers 0 and -3. Okay, so I wanted to do just a couple more examples of this to make sure that we're solid on these. Okay, so example number 2. Let's take a look at 2 different negative numbers. So let's do -13 and -5. -13 and -5. Now, if these had both been positive, I think everyone knows that 13 is a bigger number than 5. So if it was 13 and +5, then we would have had that 13 is greater than 5. But because they're negative, it's going to work in the opposite way. So if we go back up to our number line up here, and we go ahead and look at the number line we drew, we notice that there's no room to actually graph -13 and -5. But what we can do is we can sketch another quick number line down here. Okay, and your number line doesn't have to be perfect. It just has to get the basics down. So for number 2, if I sketch a number line, rather than having to write every single number, we're just going to count in 5s. So I'm going to write 0 in the middle, and then we have -5 to the left, -10, and -15. And then most people know that -13 is actually between -10 and -15. So when I do -13, that will be somewhere around here. So there's -13. And then -5, we can see, is actually to the right of -13. So -5 is over here, and I'm doing that in blue. So then looking at these numbers, comparing -13 to -5, is -13 greater than or less than -5? Well, we can see that -13 is actually to the left of -5, and remember that less than goes to the left, greater than goes to the right. So that means -13 is less than -5. Okay? And with those couple of examples, I think we should be good. Obviously, most people already know how to deal with positive numbers. So, for example, if you compare 3 to 1, I think most people know that +3 is greater than +1. But you can still use the number line, right? But most people think of a larger number when it's positive. Everyone already understands that. So we'll go ahead and skip that part of it. That should be pretty straightforward. All right, so the next thing I wanted to talk about, this is still section 2.1, is absolute value. So absolute value. So the basic idea here is absolute value looks like two vertical bars. So for example, absolute value of -2 would be two vertical bars, one bar to the left, one bar to the right, and then -2 in the middle. And what it means is it's actually going to be the positive version of the number. Okay? Means the positive version of the number. Positive version of the number. There's a lot of different ways of describing it, but since it's the positive version of the number, you can think of absolute value as always positive. Okay, it's never negative. At least what's on the inside. Okay, so if you take absolute value of -2, that's going to give you the positive version of the number. So, well, what's the positive version of -2? Well, you just get rid of the minus and it becomes +2. So this equals +2. And that's our answer. So it's actually just one step. Okay, if that's our first example, let's take a look at absolute value of a number that's already positive. Okay, so for example number 2, let's do absolute value of 23. Absolute value of 23. Now my question for you is, what's the positive version of a number that's already positive? Well, it's just the number. Okay, so the absolute value of 23 is actually just going to equal 23. 23. Okay, so with -2 up here, because it was -2, we had to get rid of the negative to get +2. That's the positive version of the number. But here, because 23 was already positive, we just keep it positive, and that's our answer. All right, so most people find absolute value to be pretty simple when they think of it this way. It's just always going to be positive, regardless of what the original number was. Okay, and then of course, there's special cases. Like if we look at 0, what do you think the absolute value of 0 is going to be? Well, is 0 positive or negative? The answer to that question is 0 is actually neither positive nor negative. So the absolute value of 0 is just going to still be 0. Okay, it's neither positive nor negative, but you can't, because you can't write a plus in front of 0 or a minus in front of 0, the absolute value of 0 is just 0. Okay, and then there's just one more case I wanted to talk about. Now this one might not show up as much in your homework, but I wanted to talk about it really briefly. So let's say we have a minus outside of our absolute value, and then on the inside we also have a minus. So let's say we have minus absolute value of negative 37. Okay, so negative absolute value of negative 37. So what happens here is the minus on the inside becomes positive. That minus on the inside becomes positive. But the minus on the outside, because it's not inside of the absolute value, the minus on the outside actually just stays the same. Okay? Stays the same. And the reason it works this way is with your absolute value, it only makes the inside positive. Okay? It doesn't affect anything on the outside. So because this minus here is on the outside, this minus does not change to become positive. So if you take negative of the absolute value of negative 37, you're actually going to get the minus on the outside stays the same, but the minus on the inside becomes positive, which means that we actually get negative 37 as our answer. So I know I said absolute values are always positive, which is true, but the thing is here, we got positive 37 on the inside, but because there was a minus outside the absolute value at the very end, that makes it negative of positive 37, which is negative 37. Okay? And so that's a little trick there, but once you get used to it, it's pretty straightforward. And you got to resist the urge to cross out the minuses at the beginning, because this minus is actually inside of the absolute value. You can't cross those out at the beginning of the problem. So the correct answer should be negative 37. Okay? All right. All right, so the next thing in section 2.1, actually the last thing that we're going to learn in 2.1 is word problems. Okay, and we're just going to do these by example. Now these are real-world examples of integers. Okay, and the instructions here are represent the quantity as an integer. Represent the quantity as an integer. Okay, and these are word problems, but they're actually very simple word problems. So hopefully they won't be that difficult. So I'll do a couple of these. Number one, example number one, says that the bottom of a deep trench in an ocean, the bottom of a deep trench in an ocean is estimated to be 12,913 feet below sea level. Okay? So 12,913 feet below sea level. And we want to represent this quantity as an integer. So here there's nothing to solve for It's actually one of the simplest word problems ever created. All they really want you to do is represent this 12,913 feet below sea level. And if you think about it, below actually is going to end up meaning negative. So above 0 is positive, below 0 is negative. So if it's below sea level, what they actually want us to write here is negative 12,913. Now if it had said 12,913 above sea level, well, above 0 is positive. So we would have written positive 12,913. But because it says below sea level, we actually write negative. Okay, so negative 12,913 is our answer. So here with these problems, you just take the number they give you, and then you try to decide whether it should be a negative or a positive. But it does involve some reading, so you have to read what they say. But in general, if it's below, if it's a loss or a debt or below 0, that's all going to be negative, whereas above 0 is always going to be positive, or a gain or a profit. Any of those things are going to be positive. Okay, so let's see another example of this. Okay, example number 2. A company posted a net income gain. A company posted a net income gain of $13,992 million. Okay, $13,992 million. Okay. So just like the last problem, you take the number they gave you, which here is 13,992, and you have to decide whether it's going to be positive 13,992 or negative 13,992. Well, how do you decide that? Well, you just read what they wrote. So here, because they're saying a gain is actually going to be positive. Okay, so gain is positive, whereas a loss is negative. So if you lose money, that's considered to be negative. That would be a negative integer. Whereas if you gain money, that's a positive integer. So here, the answer they're looking for is actually positive 13,992 million. And this is in dollars. So positive $13,992 million. And notice because it's positive, we don't even write the plus. It's automatically a plus if you don't write it. Okay? And on the last problem, I did not write the units. That's really already written for you in MyMathLab. That's why I kind of got lazy about it. So on MyMathLab, they're going to either write feet below or they're just going to write it like this. So in this case, they didn't write the units, so they didn't write feet. Whereas on this problem, in MyMathLab, they already have the dollars and the million written for you, so you're really only going to be typing in this part. Okay? All right.